All right, we're starting Unit 2. So in your OneNote, you should now go back and create a new section and call it Unit 2 Topographic Maps. If you haven't done that yet, make sure that you do that and then come back and then start taking the notes from here. We're going to just do some review about compasses. Remember, we just looking at north, south, east, or west. And those are called cardinal directions. We can get more specific with directions and go to northeast, southeast, northwest, southwest. You can see them on the map, on the compass, I'm sorry. And we can even get more specific with north, northeast, east, east, northeast, depending on where you are. So if you were here, it would be north, northeast. But here it would be north, northwest, but between these two, this one, then you'd be west, northwest. But those are, you've got a lot of different degrees that can be in north, northeast, or north, northwest. So a lot of times what we are going to do in here is we're going to do bearings, and bearings are exact degrees. So the bearing for north was right at the top of the compass. It's going to be 0 degrees. East, on the compass that we're looking at here, every long line is going by 5 degrees. So we've got 75, 80, 85, 90. So east would be 90. South, right here, we got 165, 170, 175, 180. And west, 255, 260, 265, 270. So that's your basic directions or bearings. All right, when we're looking at a map, you're going to have to know facts about latitude and longitude. So their latitude's known as parallels. These lines run east and west, so this is tricky. So see, these lines are running east or west, but they measure the distance north or south of the equator. This is the tricky part. So you can see it's 10 degrees north or 10 degrees south of the equator. These are parallel lines, they never meet, but you can see from the picture that as you get closer to the poles, the lines get shorter. So the equator line is the longest. Longitude lines are known as meridians, and they run north or south. You can see the lines running north and south, but the tricky is that they are running east or west of the prime meridian. So the prime meridian is labeled right here. It's the red line going through Greenwich, England. And you can see there, this would be 10 degrees. This would be west of the prime meridian. And this 10 degrees would be east of the prime meridian. They are all get closer to the poles, so they meet, whereas latitude lines did not. But they're all equal in length. None of them get smaller. So that's the longitude. When we measure on using our compass on a map, we have to realize that the true north and magnetic north are not going to match up, because true north is the very top of the earth, but magnetic north is going to be off just a little bit. And that's because we have an iron core and we have this lovely magnetic field which protects us from the sun's rays. So even though the sun can spew out solar winds, we're protected from that, and it doesn't take out our cell phones. So when you look at a map, when measuring a map, we have an isogonic chart. So this is what it is. And it's saying that here is the agonic line, and this would be where true north match up with magnetic north. So that would be the 0 degree line. But when you go east or west in the United States, you can see these lines are going to bend. So when you're having this, we say these degrees as you go, this is going towards eastern United States, but the numbers are west because you can see the line is bending towards the west. So this line is bending towards the west. So that's bending that way. And then, whoops, towards the west. So that's why we say these, even though we're on eastern United States, they're measured as west. And we say, because they're west, remember that, you're going to add to your, like whatever the declination is, you're going to add that to your bearing. So add declination to bearing. And if you're west of the agonic line, the lines are bending towards the east. So they're bending this direction towards the east. So we say east is the least, and we're subtracting our declination. So we take your, whatever your bearing is, you're going to subtract the declination. So if it's west, and it'll tell you on the map, it's going to add. If it's east, it's going to subtract. And the magnetic declination can change. So if you are going to do a hike, because the topographic maps are usually very old because land doesn't change that fast, so they don't update them very much, that you would want to check. So we could look and see, where are we for West Fargo? We'll do the school. So there's Cheyenne. We get the latitude and longitude, and then we'll just hit calculate. You can see at the top it says 2 degrees 50 feet east, but so we're only 2 degrees off for declination. So even my chart that I just showed you in the PowerPoint, you can see the agonic line here kind of goes through Wisconsin. That line probably has shifted way over there, and because we're only 2 degrees. So because if we look at our old chart, we would say from here, we would say probably it's West Fargo 6 degrees, but based on the new data, we'd say we're pretty close to 0 with only 2. And so you can check this website to see what it actually is, if you were actually going to go on a hike. Okay, let's quickly review. What are the bearings for northwest? So you can look northwest, and so what are we going to, I estimate it's 315. Southeast, we can estimate 135. South, we talked about, we can see right on the compass, 180 degrees. West, 270 degrees. Okay, now then we look at the bearings, we could read our directions. How about 300? So 300 is right here. So it's between west and northwest. So we'd say it's west, northwest. 50 degrees is right here. So it's between northeast and east. So we'd say east, northeast. And 200 degrees is right here. So we'd say it's south, southwest. Okay, now practice with magnetic declination. So you're going on to take a walk from Tacoma to Mount Rainier. So I just put this map on here so we could see. And you look on your map and turn your compass to a bearing of 120 degrees. But then we look to see what is the declination for Mount Rainier. So you can see this is our magnetic north, and it's this direction of true north. So we say it's east. It's also labeled east right there. So if it's east, we say east is least, which means we're going to subtract. So if we have 120 degrees, what do we subtract? We'll look at this number there. So it's minus 15.6 degrees. So we can say 19.144. So we would say we're going to, we would set our compass then instead to 104.4 degrees to go the right direction. So this is the direction that you would actually set your compass to if you account for magnetic declination. So that true north, you're going in the right direction. What if you were on the other side of the United States and we're in Maine and we're going to Acadia National Park? So we're in Maine now, so put the map there. So you're hiking in Acadia National Park and want to hike toward the beach on the Atlantic Ocean from a trail you're currently on. You look at your map and set your bearings to 220. Looking at the magnetic declination, what would you set your compass to account for the declination? So now you can see we're 16.3, but this magnetic north is to the west of true north. So that means now we are going to say west is best, and we're going to add. So this time you take, 220 degrees, and we're going to add 16.3. So we have 0.363, that. So now this time we would set it to 236.3 degrees because we could see on here that the declination was west. Okay, so you can stop with these notes now, and there is a practice problem on Schoology.